Welcome to the SolidCAM UK Technology Centre and welcome to our latest event. Today we have a selection of partners for you with machine tools, cutting tools, work holding, measuring, simulation, testing, and together we'll be demonstrating how we can collectively show you a total solution for manufacturing and machining. So throughout the event we'll be using SolidCAM software, showing the various strategies and including our powerful iMachining for fast metal removal. And before I hand you over to Ian and Ben, who will go through the live cutting session, I just want to remind people that we are cutting things live today, so we'd encourage you to ask questions throughout the session and hear the answers that you all want to hear about and things like that. So enjoy the day, don't forget to ask questions, and we'll see you at the next event. Thanks.
Good afternoon and welcome to SolidCAM UK Technology Centre here in Barnsley. We've had the technology centres set up in the UK for several reasons. Primarily, we make a lot of claims around the software, saying how good it is, how we can make time improvements for customers, but we need to prove that. So that's what we're doing today. We've got machines set up here so that we can actually prove any claims we make. So it's here for that reason. It's also here so that we can show partner products off as well. So we're supported today by 6 partners on there, and we'll have interviews with those throughout the presentation this afternoon. So we'll have interviews from Fen Tools, from Bloom, from Romy Machines, from Schunk, from Heimer and from CG Tech, all providing different parts of the manufacturing solution. So this is what this is set up for. Unfortunately, in these current circumstances, the primary purpose of this was to have seminars and have people come round, look at different products, look at the software, look at the machines on here. But we can't do that now. So we're now doing the next best thing, which is now inviting you in electronically so that you can see exactly what's going on. So we're running a couple of demos on here. The main demo is on the DCM 625 axis here, which is already started on there. So we're already starting doing some cutting on this. First of all, actually, before we get there, we got some apologies from last week. For those who joined us last week for this presentation, we got about 6-7 minutes into it when the BT network went down in the UK and we lost all internet access. So apologies for that. So we're restarting again today. So I hope you enjoy this afternoon. If there's any questions which come out of it and you want to ask any questions, there's a possibility to do that through the seminar software. So do that. We can answer them as we go along. Enjoy this afternoon. I'm going to pass over now to Ben, our applications manager, who's going to take you through the next part.
Yeah, thanks, Mark. So welcome to the seminar. As he said, the machine's running at the moment. So we're cutting iMachining at the moment, which is our fast metal removal. We'll have a little presentation on that. Throughout today we're going to have different presentations. We're going to show different functionality inside the software as well. So we're going to be showing some 5-axis simultaneous. We're going to be showing some barrel milling as well. We're going to be showing 5-axis engraving and chamfering as well. So we're just going to have a quick look at the how we've programmed the iMachining inside SolidCAM then, and a little bit more about what iMachining is first of all, and then we'll come back live. We'll be able to see the machine cutting and we'll be able to have a look further into the software.
So we're first going to have a look at a presentation of SolidCAM. We're going to have a look at the features and benefits of SolidCAM, and we're also going to have a demonstration inside the software as well of the part that's been programmed for today's seminar, how it's been programmed, and then we will cut back to the cameras in the machine to have a look at this being cut live. So SolidCAM are leaders in integrated CAM. The major benefits of using SolidCAM inside SolidWorks are that we have the same look and feel through a seamless single window integration. There is full associativity inside SolidWorks as well. So any model changes that are made will automatically update the toolpaths in SolidCAM. SolidCAM is working inside the SolidWorks assembly mode to define fixtures, tooling and vices, and we've also been gold partners with SolidWorks for the last 17 years. We have a complete integrated solution inside SolidWorks. We are a modular system, so we can add the specific modules needed and when needed as well, so you don't have to have all the modules all at once. If you buy a new machine and need extra modules, these can be plugged in afterwards. Moving on to our iMachining module. So this is our high-speed roughing operation inside SolidCAM with a technology wizard built in as well. So we get increased productivity due to shorter cycle times, up to 70% and more cycle time saving. We dramatically increase the tool life and unmatched hard material machining as well. We see outstanding performance when using small tools, and we can use iMachining on 4-axis machines, 5-axis machines, mill-turn machines as well. High programming productivity and a very short learning curve. The unique wizard will optimize the feeds and speeds for you, including the depth of cut based on the stock and the tool material, as well as the machine specifications. So this takes the headache out of programming these high-speed roughing operations. So iMachining comes in 2 stages, all built into the same operation. The first stage of iMachining is to create an intelligent toolpath, so an efficient tangential toolpath which will ensure constant tool load on the machine. And then the second part of iMachining is the technology wizard. This will calculate the cutting conditions for any given machining operation. So this will calculate things like the speed, the feed, the depth of cut, and also the cutting angles. So we can have variable cutting angles. You can see there from 80 degrees to 10 degrees we can have set the maximum and minimum cutting angles based on what we wish to achieve, or we can let the wizard handle those maximum and minimum based on the material parameters that it's been given. You can see there on the left hand side at 20 degree engagement the feed rate is a lot higher than it is on the right hand side at 50 degree engagement. So iMachining will fluctuate the feed rate based on its engagement and its contact points as well. Also, the patented unique features inside iMachining are we have the morphing spirals only in iMachining, as you can see there on the left, so with varying width of cut. And on the right hand side we have intelligent separation as well for iMachining, so we can separate areas with channels to maximize the spiral area. You can see there on the left hand side we're machining up to a wall. Now once we're machining up against the wall we're going to be full engagement with the cutter. So what iMachining does is it separates this section out and machines in a sort of lace strategy here against the wall, and creates these 2 channels here to leave 3 final areas for spiraling. So you can see on this next slide here we now have the 3 morphing spiral areas that are being machined by iMachining. This is more efficient and better for the tool. So optimal speeds and feeds for iMachining. So the technology wizard will calculate these speeds and feeds for you based on data that we have initially entered. So we would initial the material properties. We obviously select the geometry that we want to machine. We have the tool geometries and we put in the machine parameters. This will then calculate all of these that we see in red here. So the technology wizard will calculate the depth, the feed rate, the step over and the spindle speed, all synchronized together. Now the depth of cut is calculated inside iMachining, and it is calculated on an optimal depth of cut to reduce vibration. We're looking for an ACP close to a whole number. Now if you look on the left hand side here, ACP1, that is one full engagement with the tool. This is minimal vibration. If we look on the right hand side here, we have many contact points and we have an ACP of 4.5 as we hit the top, so we have a gap. Now this will produce vibration based on the fact that the tool has load and there is a flex point at the top here. With this one here, we're in full contact on the left hand side here. Now the cutting forces are only now in one direction, to the left. On here an ACP of 3 would be fine as well, so we're looking for an ACP closest to a whole number as we can, and again iMachining will calculate this for us. iMachining is a patented technology. No other system can use our technology. You may see other systems using the spiral or morphing toolpaths, but you won't see any system using a spiral toolpath and also calculating the speeds and feeds and depths of cut using our technology. So let's have a look at a demonstration of the component that we're actually cutting live on the machine today. So this is the component. You can see it's all set up in SolidCAM. If we have a look at how it's been set up on the machine, you can see here we have it in the vise and we have this round billet stock sat up in a vise. So we first want to rough out all the material, leaving the rough shape of this component. So we're going to use iMachining, 3D iMachining. The stock is automatically calculated, and the tool we're going to use for this today is the Fen 12mm end mill. So for iMachining I need to set up the iData, which means we need to tell it what the helix angle is and the grade of carbide that we're using. We also told it the material we're cutting, which is the N24T. And you can see here iMachining has calculated 2 step downs, 23.36 depth of cut. We're in the green, which means we should get no vibrations. Now this is the machining level, so you can see as I slide the machining level up and down, the speed, feed and step overs all change with each other, so they keep the relationship between each other, maintaining the cutting conditions. So we can see this has calculated the toolpath with those 2 depths of cut. We've also got a scallop on there of 0.5 as well, so we take the large depths of cut first of all and then we go back over the job, leaving a 0.5mm scallop all the way around the shape. So you can see here this iMachining working. You can see it live at the bottom left hand corner of the screen there. So you can see the chips come away nice. This is full depth of cut, high feed rate and a small step over. So on here we're looking at roughly around about 10% step over, and like I said, we're at the full flute length on the depth of cut. You can see it there creating a scallop, so the 0.5mm scallop on the component. Now iMachining works in 3+2 as well, so you can see here now I've got the datum position pointing at the 90 degree, so we're going to rotate the axis over 90 degrees, again using the same tool. I've got the machining level up to the top, we're nice and green, so we're going to calculate that toolpath, and you can see the toolpath's been generated. We're now going to cut all that stock from this position here. So again, it's stock aware, we've not got any fresh air cuts, we're actually going to only machine where there is material. And you can see it's doing that 0.5 scallop on there as well again. So we'll maintain a nice shape for finishing on the component. You can see there it's getting into all those areas that we couldn't get to when we were at the 0 degree position. We're collision checking against the holder and the vise as well. Now this is iMachining, 3D iMachining, and again now we're around at 90 degrees and we're also spun the C-axis 90 degrees. This time we're going to use a 8mm end mill from Fen. Again, we've given it all the helix angle and the grade of carbide and the material it's cutting. So this is, again, because we're fully stock aware, this is a little bit like rest roughing, because we're going to now rough out with that 8mm tool wherever the 12mm tool couldn't get to. So you can see here we're just going to nibble away and really take those little tight areas out. Now you can see the cutting down at the bottom left hand side, that is full speed, that's not been sped up. The maximum feed rate on this toolpath is about 7,000 millimeters a minute on the feed rate. So let's have a look at this cutting live on the machine now, and we can see iMachining running.
Yeah, thanks. So as you can see, the machine's running. We're running iMachining, as you saw in the demonstration there. So this is the 12mm end mill from Fen. We're running at 183 meters a minute, 0.08 chip thickness. We're at 23mm depth of cut with this tool. So we're quite using all the flutes. You can see we're tipped over at 90 degrees now. You saw some of the simulation and on live cutting in the presentation there as well. So we had a couple of questions come in as well while we was watching that presentation. What's the difference between iMachining and other toroidal software? I'll let you answer that one, Mark.
Okay. Well, as people are probably aware, a lot of software now has got similar looking toolpaths within it. And hopefully in the presentation which you've just seen, some of the differences will be highlighted. But let me just recap on those, because there's probably two fundamental differences between iMachining and, if you like, standard trochoidal type cutting. The first one is actually in the toolpath itself. Other software will use a constant step over, so from the, if you like, the finished shape of the component, the toolpath will be a series of offsets from that shape. So it's a constant step over on there, which means the constant feed rate throughout the entire part. iMachining is different, because when you're using the iMachining on there, it's going to morph between your start geometry, your billet size, your stock size, to work towards the finished component size. So what you've got there is a much more efficient toolpath. On the flip side of that, the step over isn't constant. So if we were to leave the feed rate alone and not alter it within the toolpath, the chip thickness would vary through every point of the cut. So what iMachining will do, iMachining will then take over at that point and maintain the chip thickness. So when it's a narrower cut and the AE is not up to its maximum on there, it'll cut faster. It will increase the feed rate accordingly to maximize efficiency on the part. So that's a fundamental difference. The actual toolpath will look a slightly different shape to competitors, if you like, but based on that we can be a lot more efficient, because we've got a more efficient toolpath because we're morphing, but also we're actually changing the feed rate to maintain all the chip thicknesses and make the part a lot faster. The other main fundamental difference is we'll give you the cut data to work with. there's a technology database built into iMachining on there to give you that information. The basics of this technology is that we're now going to cut this fast enough to heat the material up to get it into a state that we can cut it, if you like, on the opposite side of the heat curve to the to conventional machining. So conventional machining, the faster you go, the hotter you'll get in the cut, until it gets to a point, to a peak, in which case the material gets into its sort of plastic state and it gets cooler again, it gets easier to cut. So what we're giving you within the technology wizard inside iMachining is a map of how to get to the optimum cutting data. So there's part of that is the machine database, part of that is the material database on there. For iMachining or for any toolpath to have correct feeds and speeds, there's 4 bits of information which need to be passed across. 3 of those we'll know about, 1 we don't, which you should have picked up a little bit on the last presentation, but if you didn't, then I can give you a quick recap on there. We obviously need to know the details about the tool, number of flutes, what quality of carbide it is on there, tool length, diameter, even things like the helix angle are taken into consideration. Then you've got the machine, how efficiently can it actually cut on there, what's his maximum feed, speeds, horsepower of the control on here. So that will give you all that information as well. So put that together with, so you've got the tool, you've got the machine on there, we've got the material which we're actually cutting. The only bit of unknown on there is the rigidity of the setup and how well held that is. So that's why on the technology page, hopefully you saw on the presentation, there's a slider bar. So if you want to be more aggressive because your setup can handle it, you haven't got too much sort of tool hanging out, you're not, you're well held, if you like, in a vise or in good work holding, then you can push it. And that's why I give you that slider bar, and that will affect feed speeds and step overs to keep it in the sweet spot. So those are the 2 fundamental differences.
Yeah, so a common question that we do get asked as well at that point is, can we do iMachining with a ball nose cutter?
We can. There are other problems associated with that, but yes, it will take a ball nose. So if you're trying to get into a small cavity, for example, and you need to finish off the bottom radius within that, and you want to do without a ball nose and you want to use iMachining for it, yes you can. But there is an option in there to make it support ball noses, but the main issue, and it's something which you have the ability to change on there, is as it steps across, as it repositions, it will lift up typically by 0.08 of a millimetre, so that when it repositions at high feed, it's not rubbing along the bottom of the part. Now obviously if we're cutting with a ball nose on there, we haven't got a flat area on the tool to get rid of any cusps in the floor. So the only change you may have to make on there is, if your step over is a little bit high, is you may have to increase that retraction amount in Z so that it doesn't clip all the cusps on its repositioning.
Good, yeah. So as we said, we've been supported by different partners today. These tools have been supplied by Fen Tooling. So we're just going to have a quick presentation. Ian caught up with Gary Ridgway a few weeks ago. He's going to tell you a little bit more about Fen and what they can offer.
Hi Gary, thank you very much for joining us. We do appreciate the support of Fen Tool in our live events. So it's always good to get specialist partners involved with this kind of stuff. Perhaps you could tell us a little bit about how Fen Tool actually started up.
Certainly, Ian. Well, Fen Tools itself started in 1982 by Peter Fen, and the reason he started up was to be a little bit different from general distribution that he had currently worked under. For example, he'd always been working for companies that sold a milling cutter, a tap, a drill for an application, where he preferred to go to the more specialist and offer a much bigger range than everybody else was offering.
Right.
Okay. Starting off with a couple of agents like Alpen May, who now make Estag, and also Harnreiter on the tapping, and then he went into with Sphinx. So he offered a tool with a different geometry for different application. For example, a tapping range, we have 65 different geometries on metric alone. So it gives a vast array so you can sort out the problems.
Excellent. But obviously you just said that you started off supplying tools. At what point did Fen diversify into actually manufacturing their own tools then?
Well, how we used to do it, we used to actually design some tools and then get them made in Switzerland or Germany to our design. But to be honest, it was a long-winded affair. For example, you could make a product, we'd get it manufactured, and then you'd realise you want a few tweaks to it. So it was 10, 12 weeks every time. So in 1999, we invested in our first TX7 and a TGX from Anchor. Right. And then we went straight into manufacturing.
Oh, wow, fantastic. And what kind of capacity do you have sort of current day to offer to your customers?
What we have now, we have 3 FX7 linear machines. We have 3 Anchor MGX7 linear machines. And then we have a couple of older style anchors that we use for the roughing operations. And couple on that, we also have a Roby centerless grinder, and there's several other what I'll call second op machines to do small processes like necking, backing off, etc., where it's not really worth tying up your CNC capacity. Right. So, and as I say, we're now manufacturing on a shift system and working very, very well.
Fantastic. And obviously you're kind of diversifying as to what you manufacture. Could you tell us a bit about what products you are manufacturing at the moment?
Yes, certainly. We actually manufacture under the Fotoga banner. The Fotoga banner is actually an anagram of Fen Tool and Gauge. Okay, so it's actually it's funny because we've had lots of companies go to company's house to try and find out where we're buying this in from, and then they realise that it's actually our brand name. And let's say. So we work with, we have the A-line, which is a dedicated high-performance range for aluminium. We have the I-line, the Fotoga I-line, which is for the inox materials, the stainless steels, etc. And then we have the U-line, which is a pretty much of a new catalogue, but is actually, it's adopted all of our universal product. And also we do make some specialist high-performance thread mills, and also lots and lots of specials that are made to customers' requirements.
Fantastic. And is there a particular market that you target at all?
Well, mainly the UK market is our biggest market, as you can imagine, where we have 10 sales engineers throughout the UK. In Ireland, we also have a sister company, Kildare Tooling. We have 2 sales engineers over there, and we sell again direct to end users over there. Right. Also in Southeast Asia, we have agents in Malaysia, Singapore, and a new one in Vietnam. And we also have many other direct accounts in Thailand, Mexico, Korea. There's many. So yes, it's a growing market.
It sounds fantastic, and like I said, you know, the support that you guys give us is brilliant, and you know, we really enjoy working with sort of technical partners like yourself. Just leaves for me really just to say I'm so grateful for you sort of giving your time up today to do this interview.
No problem.
Look forward to when we can actually meet up again in person once all these issues are over, as it were.
Terrible, isn't it?
Fantastic. All right, Gary, thank you ever so much.
Thank you.
Yeah, thanks for your time there, Gary. I know you offer us a lot of support with this project and the tooling and other projects as well, so we do look forward to working alongside you again. It's great. So we were still iMachining there with the 8mm bull nose cutter that we've got there. Couple more questions come in there as well relating to the iMachining. How does it improve tool life as well?
Well, the fundamental basic of it is the tools have been designed to machine in a certain way. iMachining just allows them to work exactly as they were designed to be cut. Cutting on the full flute of the tool, smaller step overs on there, fast feed rates, fast spindle speed on there, exactly as the tool was designed to be cut. Now in some cases on there, we've got absolutely outstanding tool life. In one example, we have a customer who was making this particular component and was using inserted tools to cut out part of the component on there and let it drop away. Now he wanted to go to lights out machining, so he couldn't do that. We had to destroy this area of the part and actually make it into swarf. So we switched it over to iMachining on there. Not expecting to get many time savings, is obviously creating a slot to remove a part of the material should be a lot quicker than destroying the whole area. But no, we did get time savings on there. But then he said he's got to see how long it's going to last. He knows that his inserted cutters on this particular part, he could get 2 components out, maybe 3 on there without having to change the inserts. So obviously a solid carbide tool is a lot more expensive than just changing inserts. So we looked to see how many he could actually get on there. So he ran it until he couldn't run any more on there, and he actually got 60 components out of it. So that's a massive saving on tooling, a massive saving on time and playing around as well. So it does actually work, this technology.
Yeah, and do we use iMachining for all roofing operations as well inside SolidCAM?
I'd love to say yes, but it's not going to be the answer, because iMachining has a place, the same as any other machining strategy. If the pocket's too shallow, we won't get enough engagement on the flutes to stop the vibration. So in which case on there, maybe we're looking at a high feed tool to get that out as well. Likewise on the inverse of that, if it's a really deep pocket and we have a lot of maybe tool extensions to get down to the bottom of the pocket on there, we may not be able to, because the vibration can come into play there. But generally speaking, 85% of pockets and metal removal, yes, iMachining is perfect for it. The other 25%, the other 15%, or whatever it is, there's other techniques around, but iMachining will do most of it.
Yeah, so we have obviously HSR in there for other roofing areas as well. Like Mark said, when we're not using iMachining, we do have other roofing strategies inside SolidCAM. So we're on 5-axis simultaneous now with a barrel cutter. So this is the 6mm barrel cutter. It's got a 95mm radius on the outer with a 1mm ball at the bottom as well. Now the machine we're using is Romi's DCM 620 5-axis simultaneous machine. So again, Ian caught up with James from Romi last week. So we're going to hear what Romi has to offer as well now.
Hi James, thanks for joining us today. Obviously technical partners are a very important part of SolidCAM and what we're doing in our workshop, and we're very pleased that Romi continue to support us, especially on this second event that we're doing for 5-axis. So we're using your 5-axis. Can you tell us about what other 5-axis machines you offer?
Yeah, so we offer 2 different types of 5-axis machines. The first one, we offer a 3+2 machine for 5-face machining. The second 5-axis machine is fully simultaneous for 3D surfacing work. So yeah, 2 types of 5-axis machines.
Okay, and are these 2 machines, are they similar structure?
Yeah, similar build, similar structure, castings the same. So we have options 12,000 and 10,000 RPM, yeah. BT 40 spindle, ATC can hold up to 32 tools. Yeah. The rapid travel is 36 meters per minute. We have an X travel on both of them at 620 mil, a wide travel at 520 millimeters, a Z travel at 460 millimeters. But very, very similar in spec. The only difference is one is 3+2 and the other simultaneous.
Okay, that's cool. Do both machines have the same control on them?
Yeah, so we offer the Siemens numeric 840D control. We find this is a popular control in the market. It offers conversational programming, which a lot of people like, for simple machining operations. So you drill, you tap, your facing and so on, and then for simultaneous work, it's got some nice features on there for high-speed settings control. So it's got a varied option for both 5-face machining and simultaneous.
Yeah, but obviously in full 5-axis simultaneously you need a great CAM system to be able to drive it.
and that's where yourself comes into it, SolidCAM.
Absolutely.
So yeah, I mean, it all depends on the post and making sure the post is right to the machine. But yeah, I mean, very easy to upload the program from a CAM software, and then I mean, both 5-axis machines are very accurate. The XYZ have linear guideways for accuracy. So yeah, very accurate machine.
Fantastic. Well, I mean, obviously it's a partnership made in heaven with your machines and our CAM software. It's great that you could join us. I know how busy everything is at the moment, and you know, I just wanted to appreciate you taking the time, and look forward when we can actually get face to face again.
Right, nice speaking to you.
All right, okay. Thank you very much, James.
Thanks, James. Yeah, it's great to see what you can offer, and obviously thanks for all the support you give us with the machines here as well. Obviously we have the Romy D1000 here. We got the DCM 620, and we also have a mill turn as well in the corner. That's behind the banner that you can see behind us here as well. So we're on the barrel cutter, as you can see, 5-axis barrel cutting. We're just doing like the belly of the blade nose on here. So this is running at 8,000 RPM, 1500 mil feed rate, and on the belly itself we're doing a 1 mil depth of cut. In some of the other areas where we're doing like a flat face with the barrel cutter, we're doing 2 mil depth of cut, and that's just due to the contacts on a flat face are better. If we're doing obviously we've got a radius on the tool against the radius on the component. That's why we've gone for a smaller step down on this as well. So yeah, question coming in here at what's the advantages of using a barrel tool? I'll let you answer that one as well, Mark.
Okay, well it's a geometry issue, to be quite honest, because if you take a ball nose on there, the bigger the ball nose, the bigger the step over you can have to achieve a surface finish because of the contact radius with the part. So all the barrel tool is doing is giving you a possibility of having a very big contact radius on against the part, so that you can increase your step down or step over onto it without compromising on any surface finish. So typically, say for example, you might have a sort of 0.2, 0.3 step over on a ball nose. It might be as much as 4 or 5 mil step over on a barrel tool, drastically saving you a lot of time on there, simply because of the geometry of the tool.
Yeah, we find obviously working with the tooling partners as well that the speeds and feeds don't actually differ that much from the ball nose to the barrel. So by saving on the step down, you've actually just, you know, you're not having to slow the tool down. You're not getting the same cycle time and a better finish. You're actually getting better finish, better cycle time. You know, you get a better tool path all round there as well. A couple more questions come in as well about the barrel cutter. But I have got a little presentation on the 5-axis barrel cutting and how we've programmed some of the tool paths here, so that may answer some of the questions. Then when we come back, we'll just review the questions and make sure we've covered them in the presentation as well.
To show you some of the 5-axis strategies we've used for this component today. So the first strategy I want to show you is the parallel to curves that we've used on the face of this job. So we selected a single face to machine, and I've selected a single curve to follow, so we're going to stay parallel to that curve. The tool we're using is the barrel cutter. So this barrel cutter is a 95 radius on the outside, so 6 diameter, 95 radius, and we also have a 1 mil radius on the bottom of the tool as well. So on the toolpath parameters, we can see we have a 2mm step down, so 2mm step down with the barrel tool, and we've told it we want to climb mill as well, so we should always climb with the barrel cutters. And then instead of tilting over at an angle, I'm telling it to use the contact point and the barrel section. So we're contacting the geometry with the barrel section at a given line parameter, so in this case 10%. So you can see here we sweep across the face, leaving a nice finish on that face. So again, using the 95 rad. So in this case now we want to finish the underneath belly. So again we're going to use parallel cuts this time, so we're simply just going to select the face. I'm going to tell it to work around the Z-axis using a constant cut. We're using the same tool, so the 95mm radius tool. Tool parameters this time we're using a 1mm step down just because we've got curvature on the face that we're cutting as well, and we're using climb milling again. And this time we're using contact point barrel section, and we're varying the cut, so between 10 and 5%. So as we go down the face we're going to rock over the barrel, so we're not using the same contact point on the barrel all the time and wearing the cutter out in one spot. So you can see the toolpath there has been calculated, and you can see I've got a nice sweeping link move back as well rather than lifting up and down. You can see it there on the machine as we swing around that face. You can see it in machine simulation also on there. So we're cutting in one direction and we swing back around clear using the link moves that have been set up. So again, the final strategy I want to show you is the same strategy as before. This is parallel cuts. This time we want to do the front of the component. I'm just going to do it half at a time, so I'm going to do this first half here, again using the barrel cutter, so same barrel cutter, and again 1mm step down with the climb milling and the barrel section again on there. Now what we need to do in this case is add some gouge protection, so I'm checking the tool against the drive surface that I've selected and also this second surface as well, and telling it to trim and relink the toolpath. And I'm also checking the tooltip against the wing there as well to trim and relink the toolpath and told it to stay away from that face as well. So if we calculate that, you can see as the curvature of that surface comes right in near those windows, the tool's unable to get down there without gouging, so the toolpath has been trimmed and then relinked to where it can actually fit in. And we'll come and do another toolpath to do just over the windows separately afterwards. So you can see this in simulation, and again on the machine down the bottom left hand corner there. Again we're using them nice smooth blend spline link moves as we go around. So we go in the cut direction and then we swing back round clear of the job, and we can see that in machine simulation as well. You can see it doing exactly what the machine is doing down the bottom left hand corner. So we can see this barrel cutter working live on the machine. Let's go and have a look at that now.
Yeah, so that was the presentation on the barrel milling and the 5-axis simultaneous, and now we've programmed the toolpaths on here. So the questions that came in, one was, does SolidCAM have specific cycles for barrel tools? So I went through some of the operations in there. We do have some dedicated options for barrel tooling, and there's some dedicated cycles in there as well, or operations should I say, in the software as well. I did also touch on mirror machining as well, and SolidCAM supporting mirror machining. One of the questions is, can all toolpaths be mirrored, and does the toolpath get reversed as well? I'll let you expand on that a little bit, Mark.
It's a very simple question. Yes. we can, there's options within all cycles or available on there to mirror the entire part or mirror individual operations within the part. And it's automatically, what it does is generate new operations and automatically reverses the cut direction for you as well. All the angles, all the 5 axes is all reversed. So if you're working, say, in automotive, in aerospace type works, where you've got a left hand and the right hand component, within a few clicks on there, you've got that already done. You just program the one side.
Yeah, so the I think I showed it in the presentation. I just flipped it about the I flipped it about the XY plane. So we did one side of the wing here, and then we flipped it over. This is doing the belly at the moment, so we're not quite onto that bit at the moment. But we will be shortly when we're coming over the top of those, over the top of the windows on that component. So like I say, this barrel cutter here is 95mm radius on the outside, and a little 1mm radius at the bottom, so effectively a 2mm ball nose. So we do also use it as a ball nose, so it's a bit of a 2-in-1 tool. I'm using the side of the cutter as a barrel cutter, and then I'm going and picking out some rads at the bottom where it meets the plinth at the bottom and blends in. We're picking out and using that cutter as a ball nose effectively as well. Any more questions come from your side there, Mark?
No, there's nothing coming on here at the moment.
Okay.
Do you want to jump to Heimer?
Yeah. So the tool's obviously been supplied by Fen, but the actual the back ends or the holders have been supplied by Heimer. So we've got a quick little interview from Phil Crawley at Heimer. So we'll go to Heimer now, and when we come back, we'll see more of the barrel cutter running.
Hi Phil, thanks for joining us today. You know, I keep saying this on all these discussions I'm having. Without the support of industry partners, we would struggle. And Heimer have spent a lot of time and effort working with us, so we really do appreciate that. So thanks for that. Part of what we talked about in our previous demonstration was the importance of tool holding, especially when you're machining in 5-axis. And I know one of the things that you guys specialise in is shrink fit. How important do you think shrink fit is for 5-axis machining?
Well, I think we see typically it's the tool holding solution of choice, mainly really because of access, because we're able to download the CAD drawings of the tool holders, so you can do your full simulation to make sure there's no collision. And what we're about is kind of reducing tool overhang. So with the geometry of they're so slim, we go down to a 1.5 wall thickness. We're able to keep the tools as short as possible and really kind of optimize the whole performance.
You just mentioned there about the CAD drawings that are available. Are these available from your head office for all of your holders?
Yeah, you can just download them. It's a free service. You have to make a registration. But once you've done that, then you can download any drawing, any extension, any cutting tool, so you can build up the assembly ready to go, ready for your CAD/CAM process.
Right. And one of the things that we noticed as well when we were kind of setting tools up is if the tool's not balanced, it can have a massive effect on the performance of the tool and the outcome of the finish. I know balance tooling is something, again, that Heimer specialise in. Yeah, could you just talk us a little bit through that?
Yeah, I think, one of the things that we see, and really when we talk about, if we can take mould and die as a good example, that we're really trying to achieve the best surface quality we can in one pass. And if we can do that with a balanced tool assembly, we have a good chance that we have no vibrations going through the tooling, so that we can really go from a roughing situation, sometimes even to reduce the need for a semi-finishing operation to go straight to finishing and achieve the surface quality you need. and only when the whole assembly is balanced can we guarantee that.
Right. And I suppose the tool holder geometry plays a large part in that as well, does it?
Well, this is the thing that we have. We have what we call our power shrink range, for instance, and we here in this case add mass to reduce vibration.
Right.
So when you see the performance between a normal slender chuck and a power shrink chuck, it's really like night and day.
Right.
And if we can really eliminate one operation, you can only imagine the potential savings in that.
Yeah, absolutely. I've always been very impressed with the gear that you guys provide. Phil, it's been brilliant to talk to you, and we do appreciate the support of Heimer. It's critical to what we're trying to show at our tech centre as well. So for now, I'd just like to say thanks very much, and I look forward to when we can actually meet up and do a live event together.
Okay, well, thank you for inviting us.
No worries, thanks for that.
Thanks, Phil. Yeah, good little explanation of what you do there as well. Obviously we're using the heat shrink holders today for this seminar. Really good holders, and some good stick out as well on them for the 5-axis. So we've got a shorter tool as possible, but we've gained the length by having the long series holders on there as well. So while this is still barrel cutting, just wanted to talk a little bit about the technology centre we've got here again, and what we do from here as well. So this is where we're all based. We have a team of engineers based here, where we do support from this building. We do training, we do any site visits and things like that. We are all based in this central location here in South Yorkshire. So we deliver support to our customers. We do that through the web or on the phone. We can do remote sessions. We can help you out in any way possible. Training again is based here. Currently, with the current situation, we're doing training remotely, so everything still operates as normal. The training is exactly what you would get if you was to come and physically visit here. It's just done all remotely instead. Over the broadcasting software that we're using today as well, so it's exactly the same as you would see here. We also deliver other services as well, so we write all our own post processes. I'll let Mark expand on the post side of things and the post team that we have here as well.
Thank you. We've got dedicated post-processor writers here for the more complicated machines. I'll run through a little bit on there in terms of how it's set up. Sort of standard post-processors like your 3-axis, 4-axis, and even 5-axis come under, if you like, your everyday types of post-process on there. Then we've got the main team will handle that type of work on there, because, we've been working in this area for a long time now, got a lot of experience in there. What we've done recently, invested in adding 2 more engineers to the team, specifically for sliding head machines. So the more complicated mill turns, for when you've got multiple axes, multiple channels, or everything happening in a very small working area, we've decided we needed to have dedicated engineers to cover that discipline. So we've got 2 engineers working away on that project at the moment. So they're predominantly covering, as say, the sliding heads, the citizens, the stars out there. So we've got good coverage on the machines. The software, as you'll see in a little while, is already there. It's all there to support the multi-channels, the channel synchronization, the full machine simulation of these parts or of these machines. And the post-processors are there now as well and can be adjusted, because we find with any post-processor, one customer may well want something completely different to the customer up the road who's got the same machine. So we can handle that from the UK because it's all local support for these post-processors. We write them here, we support them here. So again, on the complex sliding head type posts on there, every machine is subtly different. Every customer is going to have slightly different requirements. We have the ability, we will have the ability when we're allowed back on site to actually go out, prove the post-processor with the customer, make sure it's exactly as he needs it to before we can leave it with him. That team, as I said, is dedicated and all based in the UK.
Yeah, I think that's the important point there as well, that all the support's done from the UK, the post-processes are written from the UK, training's done from the UK for our UK customers. So everything's local. We don't have to go anywhere for support. We don't have to wait. We've got no time zones to factor in or anything like that. It's all here in the UK from this facility here. So that's the services and things that we deliver here from this facility. One of our other partners today as well that supply us here in the technology centre is Bloom with their probing equipment and software as well. SolidCAM's capable of running the probing equipment, so we can do measurement and we can do inspection using SolidCAM as well. So we're just going to hear when Ian caught up with David Mould from Bloom, we'll have a little chat with him, and then when we come back we should be onto some toolpath a little bit further down and starting to engrave the part and coming towards the finish of this part as well.
Hi David, thank you very much for joining me today. Obviously partner support is very important to SolidCAM, and Bloom have done a fantastic job of supporting us for on-machine measurement, etc. I spoke to Paul for our last event and he was telling me about the LC50 Digilog product. I know you have a software application to support this, the LC Vision. Could you tell us a bit about that?
Yeah, absolutely. Yes, thank you, Ian. Again, thank you for allowing us to take part in these events. These events are really informative and a great benefit to get the message out there. And it's a pleasure to join SolidCAM and the other guys. Yeah, thanks. I want to talk a little bit about LC Vision. As you said, Paul introduced our brand new laser system, the LC50 Digilog. And LC Vision is the application suite that's going to run concurrently with that new product. Yeah. So it's absolutely brand new, straight hot off the press. It's a suite of applications that allow you to get the most out of that new laser, that new Digilog technology. I think as Paul had introduced, the laser system, which Bloom is probably well found with, is now incorporates with it an analog concept, which basically, to break it down in a summary really, it allows us to capture much more cutting tool information in a much faster time. And so coupled with the LC Vision application suite, we will be able now to just offer so much more functionality and applications for customers to be able to really control their tool geometry on CNC machine tools.
Okay, and are there specific benefits that the customer is going to get from the LC Vision product?
Yeah, absolutely. because we can capture so much more data now, it's possible to not only be able to measure and check our tools live on the machine at the live cutting speed that you're going to be operating with, but also to allow you to put that into compensation. So you can start to take that data and use it now to apply to correct your tooling live on the machine in a much, much faster way than was ever possible previously.
That's brilliant. And do you think that this product now fits into today's drive for automation and Industry 4 then?
Yeah, absolutely. That's the key to it really, is about, with previous tool measurement systems for machine tools, you've been able to capture data, and then that data can be written into tool offset files, and then operators or programmers can take that data and use it how they need it. But really everything nowadays, and allowing us to become more productive, more accurate, to get more out of every machine tool, is the ability to be able to see that data live. That's the first part of it. But then to act on that data, to actually do something with it in an autonomous way. So the operator, the programmer now doesn't have to get involved. The system can be self-sufficient. We have an adaptive solution, which kind of fits along the line of what you guys as well of SolidCAM are all about. So it fits into that adaptive element to be able to machine parts, auto-adjust it live in the cut, as I say, as faster than we've ever been able to do it before. So more parts. Well, our tagline really is that every part coming off the machine is a good part. We don't have to rework, we don't have to scrap any components. Right.
And do you see the development of the LC Vision software sort of moving into more functionality and benefits for the customer?
Yeah, at the moment, the first launch, and it's as I said, it's kind of brand new, hot off the press. There's basically two applications that we can run with it. What we call 3D control, tool control, which is being able to measure and fully compensate for round geometry, so ball nose mills and things like that. We also have a spindle control application, so we can start to monitor the spindle in a machine. So if a customer has a bit of a crash, or as part of the service requirement of the machine, the spindle now can be checked and adapted and scheduled for maintenance and things like that. But really, I think future developments from our R&D guys are all going to be based around the LC Vision, which I think will then expand itself into spindle probing as well, so workpieces can also benefit from these applications as well.
That's absolutely brilliant. Thank you very much for joining us today. It's been, it's really informative to hear what's coming from the partners, and I'm sure that those products will help move technology forward, which is kind of the aim of everybody, really. So for now, David, I'd just like to thank you for joining us. Thank you for your continued support of SolidCAM, and look forward to being able to meet up and do some live events together.
Absolutely, yeah. Thank you very much, Ian, and all the best for the remainder of this event. So thank you.
So, thank you very much, David.
Cheers. Bye.
Thanks, David. So yeah, some good technology you've got there as well. Obviously, great support we get on the machines. We've been able to probe on here and obviously do part setting accurately and easily as well. So the barrel tool's just finishing off. Like I said before, we're using a barrel tool to pick out in the corners now. So we're technically using the ball on the bottom. So we're using it like a ball nose now. So we've saved putting another tool in, another holder in there. You can see it's just running round the corners there and picking out those little bits of material. So just while that finishes off as well, we've got another event coming up this month as well. Mark's going to tell us a little bit more about that next event as well.
Thank you. Yes, we're putting on another one of these. We're trying to run these as frequently as we possibly can on there. so that we can show different areas of software, different functionality, as much as we possibly can, to be quite honest. So the next event which we're actually running is on the 26th of November. So we're literally about 4 weeks now, is it? 3 weeks?
3 weeks, yeah.
Where we'll be showing a slight twist on what we've been showing today. So we'll be fundamentally iMachining again, but this time in multi-axis. So this will be cutting simultaneously in 5 axes, or in 4 axes. We're going to be using it in that seminar. So that's going to be slight twist on what we've been showing at the moment. A little bit different as well. We'll be showing some 5-axis drilling, going around at different angles, and again we'll be showing you how easy that is to do in SolidCAM, and again more barrel machining, simply because it does save an awful lot of time. The tools are out there, they're being supplied by a lot of suppliers now, so we may not make use of them. SolidCAM supports all the different barrel types, so from oval, from lens to taper, and to the barrel forms on there within SolidCAM. So in different presentations we'll be using different forms of this to show this off as well.
Yeah, that's an important point as well. We've been able to support all the different types of barrel cutters as well in SolidCAM. So not only have you got the barrel tools where you've got oval form and the standard barrel and a taper barrel, we've also got lens tools as well that we can use in 3 axis. So the lens tool is where we have a large radius on the bottom of a cutter. And we can use it to scan in 3D where you would normally use sort of a ball nose cutter. So for instance, we may have a 10 diameter end mill as such, but with the lens on the bottom, we can have sort of a 20 radius on the bottom, which is effectively now a 40 diameter ball nose cutter. So we can gain a larger step over, maintaining the same surface finish. Again, we're just time saving. So a lot of people, when they think of barrel tools, they think straight away they're thinking of 5-axis simultaneous. Not always the case. We can use the lens tools in 3-axis as well. So the tool's just changed now. This is just doing a bit of chamfering around there. So you can see just chamfering around the plinth using the 5-axis as well. So we just roll around the corner rather than lifting up and off all the time. I just lifted up there over the top of the wing, but you can see as it gets to the corner now, we just roll around it and come away.
I did look fairly close. I take it you did test that in SolidCAM first and simulated all that before you pressed the button today.
I did, yeah. I did test that all in SolidCAM. So we got full machine simulation in SolidCAM. We also run it through Vericut as well as a secondary check. So we're going to have a quick presentation from Vericut as well shortly. That's the 1.5mm ball nose just come in there. That's just taking the edges off them wings where I couldn't get in with a chamfer tool. So that's 400mm feed rate running at 10,000 RPM. It's also going to do the engraving as well at 0.1mm depth of cut. So you can see it come in now. It's just starting to engrave the part. We're going to get some nice little logos of all the partners that have been involved in today's event all around that part. Now the work holding that we're using as well, you can see we've got the vise on there. You can also see just underneath it, you can see when when the B's at 0 a little bit better. It's got this double pot system which holds the vise down on there, controlled by air. And I'll tell us a little bit more about that. We're going to pass over to Marcel from Shunk. He's going to tell us all about the work holding that they supply us here and some of the other things that they do as well.
Marcel, thank you very much for joining us again. Obviously we're now on to the second of our 2 seminars that are based around the 5-axis. Again, without technical partners like yourself, we wouldn't be able to do this, so very much appreciated spending your time to join in with us. We talked last time about the single point system that we're using to clamp on the vise, etc. on the machine. They're obviously single items that we're using, but I think, if I'm correct, Shunk actually get involved with automation. Do you think you could tell us a bit more about how you get involved with this?
Hi, Ian. Thanks for having us again. Yeah, it would be my pleasure to talk about. So Shunk, it's traditionally people probably know us for the work holding solutions that we do, but currently I think 60% of our business comes from automation. Shunk has grippers, tool changers, and if you come in from the CNC, tool changer means something else to you, but tool changer for us means the end of arm they put in a robot that can change the gripper for you and all that kind of stuff. So we have a whole suite of solutions that goes from the end of the robot to the table of your machine. And one thing that is trending, the buzzword at the time, I guess, it's machine tending or machine automation, depending on who you talk to. And we are heavily involved with that kind of solution. And again, it's something that we want to see more and more, especially now with the Corona thing. You know, I think people are more tuned up to that thing. If you had automation before the whole thing kicked off, you'd probably be better. So when it comes to machine automation, we kind of split it into 4 big groups. So we have a solution that is unique to Shunk, we call lean automation. We have a module that you can put a gripper inside your CNC machine, like a 5-axis. That module would have a gripper attached to it, and that can go into your tool changer.
Right. Okay.
So you could have the spindle of your machine coming down, picking up the part, putting to the side, and picking another billet and putting back into the vise.
Oh wow! Using a spindle.
Yes. So you can automate using your machine. That wouldn't lend itself so well for a 5-axis machine, given the limitation on the table area, because you do have to sacrifice a little bit of that table area for your billet and finished parts. But for a 3-axis, for example, it's a fantastic solution. Starting from £5,000, you can automate your machine without any robot.
Wow.
Then you could move into your collaborative robots. Again, another big buzzword all the time. So that's when a zero-point system like we have today and an automated vise, like a hydraulic vise or pneumatic vise, which you also have, would be would be essential for that kind of application. So you have a collab that drops the part into your vise, the vise self-clamps, and off you go, and then just picks that part and loads another one. So that's kind of stage 2. That solution would cost you about £20,000, including the robot and everything else. Then you would have what we call the stage 3, which is the off-the-shelf automation systems. People probably know like Celro, RoboJob, Handler, all these guys. They offer a bolt-on off-the-shelf solution that will handle the parts for you. We tend to get heavily involved with that as well, with the work holding solution and the end-of-arm tooling for them. And then you have the final stage, which is the custom-made kind of solution. So normally you would be talking to people like ABB, Fanuc, KUKA, for that kind of solution, and that really the sky's the limit. You could do literally anything with that. Have one solution that would be handling 3 or 4 machines at a time. So when it comes to machine automation, there's a lot to learn, and we are not integrators. So we would be only supplying, the work on solution, the end-of-arm solution. If you start with the lean automation, you don't need any integration. If you go into the collaborative system, you might or might not need some integration. If you go into the off-the-shelf, you're already buying that from an integrator, so that job will be done for you. And if you go to the fully customized, definitely going to need an integrator. But what we try to offer, and we really push that, is we would love to do the consultancy for you. Yes, we will never integrate that solution for you, but we can definitely point you in the right direction. Okay. And do a bit of a hand-holding throughout the process. So, it's a bit of a daunting thing, automation. There's very little standardization into this kind of industry. So it's good to have somebody who really doesn't have a dog on their fight. We do. We want to supply you stuff, but we are not really we are not going to push you into one particular way, because we always have some solution for you either way. So we would be very honest and say, now we start with a collaborative system that will have some limitations for you. Get your head around these, and then you can maybe move into a fully customized in a few years' time. We truly offer that, and it's amazing how little people actually take on our offer.
I think it's really important that, we're obviously very reliant on our technical partners, and being able to offer this consultancy and collaborative approach, I think is very, very important. You make great points, and I'm truly thankful for your involvement with what we're doing. We're a bit short on time today, so I'm going to have to...
Yeah, I know. I can...
I could listen to it all day, but I absolutely appreciate all the information that you've given us, and really looking forward to when we can actually get face to face and do more collaborative work. So for now, Marcel, thank you very much for joining us and for your involvement.
Thank you, and all of you enjoy your webinar. Thank you.
Take care.
Yeah, thanks Marcel. As you can see, the component's finished now. So he's finished the engraving. I'm going to take the part out and give you a closer look on a camera. So I'm just going to hand over to Mark while I just do that, and we'll show you a bit close up.
Okay, thank you very much. Now, a couple of questions, or one of the questions which came in was what material it is, something which we should have told you right at the beginning on here. This is the N24T we're cutting. One of the reasons is obviously we can leave the parts around for demonstrations or as exhibits, if you like, around our technology centre. So when we do eventually get people back into here, we've got displays of everything which is going on. EN24T is a pretty tough material as well, so if we did get things wrong, it would certainly take the tool and it would certainly show you about it. So it's a good solid material to actually cut, and it maintains its sheen on there. Obviously people do cut different materials, so one of the things which we're very keen on is showing that as well. So probably in the new year we'll be showing a lot more different materials in these seminars as well. Just a quick thing on the iMachining and materials. In terms of time savings, it varies obviously from machine to machine, to tool, and from material to material what you're cutting. What we're typically talking about is time savings around the 70% mark from conventional machining strategies. So that's what we're actually quoting. Now that will vary as the materials change. So from softer materials like the aluminiums on there, you're still going to get time savings, maybe 30-40% depending on the part. But when you get onto the tougher materials, your Inconels, your titaniums and that sort of thing, then you're getting even bigger time savings. iMachining loves cutting these tough materials. The tools love cutting them if you cut them properly, which is what iMachining gives you. So you're then talking like time savings up to sort of 80-90% in some cases.
Yeah, so as you can see, I showed you the part there. The part's on the desk now. It's come out quite nice. You saw it on the camera there. So just the machine stopped now. That's the end of the component. We've got a few more things to show you though, just before we close the show off. Mark touched on earlier the support we have for sliding heads and advanced mill turn inside SolidCAM. So he's going to give us a quick presentation on that inside the software, and a little flavour of what we can do and what we're capable of. And then we're going to hear from Tim at CG Tech as well. He's going to tell us a little bit about VeriCut. I touched on it earlier. We use VeriCut here. We use VeriCut for these machines that we've got in the shop, and we also use VeriCut for helping test our post-processors and things as well. So if we have a customer that's already got VeriCut, they've already got their machine with VeriCut, it's quite nice for us and quite easy for us to then sort of use that to test our post-processor output before we come on site, giving minimal disruption then to the workload you may have in your factory. We don't need to take up too much of the machine's time. So Mark's going to do his little Swiss demo, sliding head demo, and then we'll move on to VeriCut.
SolidCAM support for Swiss turn is both comprehensive and simple to use. In this overview, we will be demonstrating this on a Citizen M32 machine. This machine is a 3-channel machine with 5-axis capabilities, multiple machining patterns and superimposition. All of these features are fully supported in SolidCAM with full machine simulation. SolidCAM supports all tool holder types, including multi-station tool holders for both milling and turning tools. Tools can be moved to different stations and dynamically viewed to make sure the tools are set to the optimum position. Programming of operations is exactly the same as it would be for any mill turn machine in SolidCAM. Here we are selecting the area to turn directly from the model and the tool from the library. The toolpath is then calculated with full support of cycles on the machine. As with all operations, this can be viewed and simulated as the machine will cut it. Even adding more complex machining strategies such as cylindrical milling is kept simple. Select the area to machine direct from the model, the tool, and SolidCAM does the rest. Once the programming is complete, the channels can be optimized to get the best cycle time on the machine. Currently the part is programmed as a single part, but in reality we want to be working simultaneously on both spindles. This is done by selecting the operation to start machining on the second spindle. Now we can see the operations working together in all three channels. Based on this, SolidCAM will automatically choose appropriate machining patterns which can be reviewed and changed by the programmer, as in some cases alternate patterns are available. The programmer has full control over the positioning of the weight codes, and SolidCAM will assist this by dynamically checking and advising any issues. Now the complete program can be simulated as it would be cut on the machine with all axes working together. This highlights any potential collisions and will show any superimposition moves programmed, giving confidence the program is correct before being passed to the machine. This can significantly reduce machine downtime. Once this has been proven successfully, the G-code can be created in a single click. And here we see the result displayed in our SyncMaster software, clearly displaying weight marks and axis patterns. SolidCAM is available for all Swiss machines. For more information, please go to solidcam.com.
Hi Tim, welcome this afternoon. Appreciate you being with us. I know you did a piece for us on the first seminar we did, and obviously this is the second part of it. I'd maybe just like to continue a bit with what we were talking about when we finished last time. I think one of the things within Vericut that people maybe miss are features that are there that have been there for a while that can offer different efficiency tools and sort of hidden features. Is there anything you can tell us about that?
Yeah, certainly, Ian. Yeah, hiya. Like you said, Vericut's a very deep product, 30 years in development, if you like. So there is, like you said, a lot of hidden features in there that our customers don't necessarily know about. So obviously they don't use them that often. Mm-hmm. But we're trying to, certainly when we get in front of the customers, we certainly try and show them as much as we can. But like I said, because the product's so deep, it's not always that you get that opportunity. So a few of those features, if you like, Ian, just touching on a few. There's a reporting function within Vericut, which is easy to use, easy to set up. It uses either HTML or PDF, or if you're familiar with Word, WYSIWYG, right, then that enables you to create good reports, inspection reports, as part of the process, if you like. So if you consider that Vericut is simulating virtually your process, there's nothing to stop us actually capturing that data and putting it into a report format.
Yeah.
So there's that feature there, which rolls on nicely to setup plans, and again that's a tool there that customers can access to enable them to make themselves more efficient.
Right.
So that's a couple of them.
Yeah. I mean, one of the things that people often ask for, and I know after being in the trade for a while, they'll have a program that's been posted out in one particular format. Is there anything that Vericut can do to sort of help that?
Yeah, so there's a post-processing tool in Vericut, which again has been there for years, Ian. It's just people don't necessarily know about it. Mm-hmm. So obviously if you've got a FANUC program or you've got a hide name program and you want to switch that into Siemens, for example, then there's a post-processor built into Vericut to enable you to do that. And the beauty of that is once you've done it, you run it through Vericut to make sure that, you know, there's no syntax errors and what the program's doing is what you want it to do.
Yeah, it's obviously the tools that you've got in there, you're checking and double checking yourself as well.
Exactly.
Obviously, I mean, we're doing these seminars online because of the current situation. You know, I'm sure it's affected you guys as well. Obviously, we're trying to help people remotely at the moment, though we are working towards getting back in the workshop, the technology centre, to do training. Are you guys kind of approaching this as well in some way?
Yeah, so pretty much the same really, Ian. So we're holding web training courses because obviously certain customers don't want our engineers on site. So we're doing web training courses as well, and they can be bespoke to the customer's requirements, or like a classroom environment, if you like, where we're just going through the standard material for Vericut. And then we always hold our seminars, if you like, towards the back end of the year, sort of September onwards.
Yeah.
And we did have 5 booked in for this year, but obviously as that gets ever closer, and you know, you might have 30 plus people there, we've pretty much resigned ourselves to the fact that we're not going to be able to deliver those. So we are teeing up. We haven't publicised it yet, but we are teeing up virtual views. So the view being a Vericut user exchange. So again, it's telling our customers what's in the latest version, ensuring they know that it's there, and helping them with tech tips and tricks, if you like, so our engineers can deliver that. And yeah, it won't be the same as, you know, seeing people face to face, but you know, it's possibly the next best thing.
Yeah. You know, we've SolidCAM as a company have tried to help people by offering licenses for them to work remotely. Is that something that CG Tech's doing as well?
Yeah, it is, Ian. I mean, we've got something called a cert license that we can issue. So as long as the customer's on maintenance, then we are more than happy issuing cert licenses, and that basically gives them a license which is separate from their main server, let's say. Right. And it enables individuals to work remotely. So a lot of companies, they can't access their main server, if you like. Some people can use a VPN, but a lot of people, if it's military, for example, then they can't, you know, because of security and what have you. So they've got to have that capability offline. So that's something that we've been offering. Well, we've been doing it with our current customers for a long time, and the beauty of it is, you know, if you've got NC programmers sat at home generating programs, they can prove it out at home as well, so they can then confidently release that program to the shop floor without even being there, and they know it's going to do what it's supposed to do.
Yeah, and you know, that's critical, and having code that you know is correct is absolutely crucial to everything, really. Tim, it's been absolutely brilliant, and you know, we can't thank you enough for the support that we get from CG Tech. So for now, obviously looking forward to when we can meet up and do something together.
Definitely,
you know, For now, I'd just like to thank you for taking the time to come and talk to me. It's brilliant, mate. Thank you.
Hey, thanks very much, Ian. Always a pleasure.
Yeah, thanks for that, Tim. As I said before, we use Vericut here, and this component itself has been put through Vericut and checked before it went on the machine. We have had a question as well about Vericut. The question is a little bit in depth. I don't know enough about the virtual machines in Vericut. So what I'll do is I'll pass it over to Tim, and he'll contact you directly about that question as well. Other than that, I'd just like to say thank you to all the partners. So that was the Fen, Romy, Heimer, Bloom, Shunk and CG Tech, all involved in today's event, and all the support they've given us. We look forward to seeing you on the 26th. Keep an eye out. The link will be being shared shortly, and we'll put all the marketing out as well. So if there are any other questions, then we'll close the show off there today, and like I say, thank you very much.
Thank you very much for taking the time to actually spend with us this afternoon. So again, as Ben said, look forward to seeing you on the 26th.